Whenever you see one of those massive steel buildings, have you ever stopped and wondered what's really holding it all together? It's not just the huge beams you can see. The real secret, the real strength, is often in the details we can't see, all these hidden rules and tiny little parts that are doing all the heavy lifting. So today, we're going to unpack one of those critical standards to show you the hidden strength of steel.
So let's start with a question for you. What do you think is the absolute weakest link in a steel building? I'll bet it's not what you're thinking. It's not the massive columns. It's not the sprawling beams. No, the answer is way, way smaller. It's the one tiny spot where all the immense forces of a structure come together.
And yeah, that way smaller answer is the connection point itself, which brings us right to our first section, the connection challenge. This is where we're going to dig into the unbelievable stress these little points are under and, what happens when they aren't absolutely perfect.
And the stakes are incredibly high, as you can see right here. Every single connection in a steel frame is fighting these immense forces like tension and shear. And if the design or the material is even just a tiny bit off, you get these catastrophic failures. We're talking about steel literally tearing apart or bending under the load like it's plastic, or bolts just being ripped straight through the steel plate. This isn't just a crack in the wall. This is total, premature failure.
And it all comes down to this one little component, which is either the hero or the potential villain of our story, the Cleat connection. It's basically just a small steel bracket that joins a beam to a column. But this one tiny piece is responsible for transferring huge dynamic loads. The safety of the entire structure literally depends on this handshake between two pieces of steel.
So how in the world do engineers stop those failures from happening? Well, they use a rule book. So for our next section, we're diving into this steel rule book. It's the super detailed, non-negotiable guide that tells you exactly how these components have to be made.
And here it is, the rule book itself, AS/NZS 1163. This is the official standard for the steel hollow sections used in these connections. You got to think of it less like a friendly suggestion and more like an ironclad blueprint that guarantees the steel's properties. By following this, engineers can predict exactly how the steel is going to perform. It takes all the guesswork out of it and, well, keeps people safe.
This really gets to the heart of it. The standard is like a very, very precise recipe for a cake. If you follow it perfectly, you get a strong, stable building. But if you decide to change just one ingredient, maybe the thickness, the grade, the shape, the whole thing can literally come crumbling down.
So that brings us to the ingredients in that recipe. Let's take a closer look at the exact details that are defined by the standard, the very things that give these connections their incredible, reliable strength.
So what are these key ingredients? Well, the standard zeroes in on three main things. First, dimensions and wall thickness, which basically decides how much force the steel can handle. Second is something called corner radii clearance. All that means is making sure the corners are shaped just right so the bolts fit perfectly without creating any weak spots. And third, and maybe most important, is the steel material grade, the actual chemical recipe of the steel itself.
And that grade is absolutely critical, because not all steel is the same. As you can see here, the standard lays out different grades, like C250 for your standard jobs and the stronger C350 for really high-load situations. The guarantee is that if an engineer specs C350, the steel that shows up on site has exactly the properties needed to do that job safely. No surprises, no guesswork.
All right, so what's the big payoff for following this rulebook so religiously? Well, that's what our final section is all about, building with confidence. Because the result isn't just a safe connection, it's a whole new level of efficiency and predictability on the construction site.
You see, following the standard creates this simple, predictable path to getting it right every time. You start by choosing a compliant square hollow section, or SHS. Then you engineer the cleats to match it perfectly. And what's the result? A connection that can be put together safely and quickly, because everything is guaranteed to fit and perform exactly the way it was designed to.
This quote from a source material just sums up the ultimate benefit perfectly. Faster installation, that saves a ton of time and money. Predictable performance, well, that's peace of mind for everyone involved. And long-term durability, that means the building is going to be safe for decades to come. That's the real-world value of what might seem like a pretty boring standard. So, we kind of end where we started. The next time you walk into a huge stadium or an airport or a skyscraper, look up at that massive steel structure. And just remember that its true strength might not be in the giant beams you can see, but in the tiny, unseen connections, all held together by a super precise set of rules. It really makes you wonder, doesn't it? Is the most important part of a building the one you can't even see?